Today we are going to learn about creating advanced 3D visualizations with Matplotlib. We will explore various techniques to effectively use 3D plots for complex data analysis, enhancing your data visualization skills. Welcome to this educational video on creating advanced 3D visualizations with Matplotlib. In the realm of data representation, 3D plots offer an extra dimension, crucial for comprehending complex datasets. They allow us to visualize relationships and trends that are otherwise obscured in 2D spaces. In this video, we will explore the capabilities of Matplotlib, a powerful Python library for data visualization, and learn how to harness its 3D plotting features. By the end of this session, you'll have a comprehensive understanding of how to create, customize, and animate 3D plots to enhance your data analysis skills. Let's dive in and unlock the potential of 3D visualizations. In this section, we'll introduce you to the 3D plotting capabilities of Matplotlib. Matplotlib's Matplot3D toolkit is an extension that allows for the creation of 3D plots. It provides a variety of functions to plot different types of 3D graphics, such as lines, scatter plots, surfaces, and wireframes.
The toolkit uses a three-dimensional coordinate system, where each point is defined by three coordinates, x, y, and z.
Understanding these axes and how they interact is crucial for effective 3D plotting. 3D plots offer numerous advantages, such as the ability to visualize complex data sets, identify patterns, and convey information that might be lost in two-dimensional plots. Some common applications include visualizing geographical data, scientific simulations, and engineering designs. In this block, we will explore these fundamentals and set the stage for more advanced techniques. Before we begin plotting in 3D, it's essential to set up our environment correctly. First, ensure that you have Matplotlib installed. You can do this using pip, a package manager for Python, by running pip install Matplotlib. Alongside Matplotlib, ensure you have other essential libraries like NumPy for numerical computations. Choose an integrated development environment, IDE, that suits your workflow. Popular choices include Jupyter Notebook, PyCharm, or Visual Studio Code. These IDEs provide features like syntax highlighting and debugging tools that facilitate coding. Once installed, start by importing the necessary modules in your script. Typically import matplotlib.pyplot as PLT and from mpl_toolkits.matplot3d import axes 3D. Create a basic 3D plot by initializing a figure and adding a 3D subplot with fig.add_subplot 111. Projection equals 3D. As you proceed, you may encounter common setup issues, such as compatibility problems or missing dependencies. These can often be resolved by ensuring the latest versions of libraries and checking Python path configurations. With this setup complete, you're ready to start creating 3D visualizations.
Now that we have our environment set up, let's delve into plotting 3D lines and scatter plots. 3D line plots are excellent for visualizing the relationship between variables over a continuous range. Begin by defining your data points in terms of x, y, and z coordinates. Use the plot3d function from plot3d to create a line plot. For instance, x.plot3dx, y, z will render a 3D line connecting the points defined by these coordinates. Scatter plots, on the other hand, are useful for displaying individual data points. The scatter 3D function allows you to plot these points, with options to customize markers, colors, and sizes. You can combine line and scatter plots to provide more context to your data, such as highlighting specific points along a trend line. Customizing plot markers and colors can significantly enhance the readability and aesthetics of your plot. Consider practical applications, such as visualizing trajectories in physics or plotting data points in geospatial analyses. Experiment with these plots to gain a deeper understanding of your data and uncover hidden insights.
Creating visually appealing 3D plots is an art that combines functionality with aesthetics. Begin by adjusting plot axes and labels to ensure they are clear and informative. Use ax.set_label, ax.set_ulabel, and ax.set_label to add descriptive labels to each axis, and customize their font size and style as needed. Color maps play a crucial role in distinguishing data points and adding depth to your visualizations. Matplotlib offers a variety of color maps accessible via plt.get_map, allowing you to choose one that best represents your data. Incorporating grid lines and ticks can improve the interpretability of your plot. Use ax.grid to toggle grid lines and ax.set_sticks to define the placement of ticks on each axis. Strive for a balance between complexity and clarity. While additional elements can enrich your plot, they should not overwhelm the viewer. Consider the plot's purpose and the audience's needs to make informed decisions about the level of detail required. Through thoughtful customization, you can create 3D plots that are not only informative but also visually striking.
Animations add a dynamic element to your data visualizations, making them more engaging and easier to understand. They are particularly beneficial when illustrating changes over time or demonstrating complex processes. To create a basic animation in Matplotlib, use the funcAnimation class from the matplotlib.animation module. This involves defining an update function that adjusts plot elements at each frame. For instance, you could animate the rotation of a 3D plot or the progression of data points over a timeline. Tools like Artist Animation offer another approach, where you create each frame as a separate plot and combine them into a cohesive animation. Consider examples such as animating the orbit of celestial bodies or visualizing real-time data streams. While animations can be powerful, they require careful planning to ensure clarity and prevent information overload. Keep transitions smooth and coherent, and provide context to help viewers follow along. By mastering animation techniques, you can transform static plots into captivating presentations that effectively convey your data's story.
Contour plots are a valuable tool for visualizing surfaces in 3 dimensions. They represent a third variable by using contour lines to connect points of equal value on a 2D plane, effectively creating a surface visualization. In Matplotlib, the contour 3D function allows you to create these plots, providing a clear view of how values change across a surface.
Define your X, Y grid and corresponding Z values to generate the contour plot.
Contour plots have numerous applications, such as visualizing topographical maps, temperature distributions, or pressure levels. Customizing contour levels and colors can enhance the plot's readability and highlight key areas. You can specify the number of contour levels and choose color maps that suit your data's characteristics. Additionally, integrating contour plots with other visualizations, such as scatter plots or line graphs, provides a comprehensive view of your data. This integration can help uncover correlations and patterns that might not be immediately apparent. By mastering contour plots, you can effectively represent complex surfaces and gain deeper insights into your data.
Color maps are a powerful tool for enhancing data representation in 3D plots, providing an intuitive way to convey information through color. In Matplotlib, color maps are accessed via plt.get_map, offering a range of predefined options such as Viridis, Plasma, and Inferno. Selecting the right color map is crucial. Consider factors like color blindness, accessibility, and the nature of your data. For instance, sequential color maps are suitable for representing continuous data, while diverging maps highlight deviations from a central point. Apply color maps to your 3D plots by setting the map parameter in functions like scatter 3D or plot_surface. Interpreting color-coded data requires a clear legend or color bar that explains the meaning of colors used. Be mindful of common pitfalls, such as using too many colors or choosing color schemes that are difficult to distinguish. By thoughtfully integrating color maps, you can create visually appealing and informative 3D plots that effectively communicate your data's story.
As with any complex process, creating 3D plots in Matplotlib can present challenges. Common issues include rendering problems, where plots may not display correctly due to hardware limitations or software bugs. To address this, ensure your graphics drivers are up to date and check for compatibility with your Python environment. Data scaling challenges can also arise, particularly when dealing with large or unevenly distributed datasets. Use normalization techniques or adjust axis limits to manage these issues effectively. Axis distortions, where plots appear skewed or stretched, can be corrected by setting equal aspect ratios using ax.set_box_aspect. Cluttered plots are another concern, especially when too much information is packed into a single visualization. Simplify your plots by focusing on key data points and using annotations sparingly. Regularly review your plots for clarity and coherence, making adjustments as needed. By proactively troubleshooting these common issues, you can create clear, accurate, and visually appealing 3D visualizations.
As we wrap up this video on creating advanced 3D visualizations with Matplotlib, let's recap the key points we've covered. We explored the fundamentals of 3D plotting, set up a suitable environment, and delved into various plot types like lines, scatter plots, and contours. Customization and animation techniques were highlighted, showcasing how to enhance your plot's aesthetics and dynamism. Troubleshooting tips were provided to address common issues you might encounter. Remember, 3D visualizations are a powerful tool for data analysis, offering deeper insights and clearer communication of complex datasets. I encourage you to experiment with these techniques and continue learning. Explore the vast resources available online, from documentation to community forums. Thank you for joining me on this journey into the world of 3D visualizations.